Okay, so this is a quick, basically a debug speedrun of basically how I solve these bugs. This isn't supposed to be like a very like 100% solution, as in like there's a lot of different ways to do it. This is just an example of how I would personally do it, and then hopefully it highlights a couple of the IntelliJ tools along the way, and it should also explain the actual bug itself as you go through this video. So hopefully it should be pretty comprehensive. So the first thing is you want to run the tests. So this is for reference TicTacToe board or TicTacToeBug1. So there's one test that fails, which is check win, and then if you go to the actual error down here, it actually brings you to the line that fails. So this line fails. I'll set a breakpoint here, and then just explain what this test does. Is this test first places pieces in a horizontal line, so you can see it's labeled horizontal. So basically this is like a line from left to right on the bottom row of the tic-tac-toe board. And then after it places all the pieces, it runs check win. So it checks whether or not there is pieces placed in a line. Check win operates based off of the piece that was just placed. So if you just placed a piece on the bottom left, it'll check from the bottom left whether or not that creates a win. So you always want to feed check win with a position. So you see that if you have a line on the very bottom, if I feed in any of those positions of the pieces at the bottom, all of them should return a win because all of them form that horizontal line. So first I want to check which value of I actually causes the error, as in which value of I results in this assert statement not being satisfied. So I'll click debug. Okay, so now I'm at the line, and then I see, okay, I equals 0. So if I click resume program, note that I'm in this for loop that will loop until I is equals to 2, and then it finishes. So if I click resume, it should keep running until it comes back to this line and it says I equals 1. So right now I equals 0, let's run it again, and we see that it errored out instead. So what that means is if I go back to this line, having I equals 0 causes this check win to malfunction. So now I can step into step win, and I know that I'm getting the result that I want is I want this to return true, as in there is a win. But currently it's returning false because this is the line that's causing the error. So now I want to inspect the function and kind of see, okay, what would cause this to return true? So it would return true if I ran this line, and that's probably the only line that would fix it. And then this line would run if this if statement was true, and this .n is set by the constructor, so it doesn't really change. So the only thing that does change in this function is streak count. So you pretty much just want to closely watch streak count and see how it changes. And then one thing to note is remember that this is a horizontal line. So the direction for the check win that you want to watch is in the horizontal direction. If you don't understand what that means, hopefully you can watch the other video about how the code is structured and how check win works. That one should explain it, but yeah, so I want to look for the direction that is horizontal, so that's going to be 1, 0. That's the vector of the horizontal direction. So that's the very first thing. So I can just click debug, and then I can just keep stepping over into that function. So right now if I look at direction, or dir is in the horizontal direction, so that's correct. So basically on this run through, I should expect streak count to up to 3, right? Because it should be 3 in a row. If you want to view the board, you can basically print out, if you go to this, and then that's the current object we're in, and then you can basically list the current board pieces. So if I open this 2D array, you see that everything is 0 except for 0, 1, 0, 0, 0, 0, 1, and 0, 2 in my current array. So it should update. My current position is 0, 0. So let's go here. Okay, so this while loop is going to start at my current position plus the direction. So if I go to this while loop, pointer 1 is at 1, 0. And then we see that 1, 0 has the correct player, and it is a valid position. So as a result, streak count is added. So now streak count is 1, and then pointer is updated as well. So now it's 2, 0. And then if I step through again, the pointer is now at 3, 0, which is actually out of bounds because the tic-tac-toe board is 0 indexed, and it's 3 by 3. So this is out of bounds, and the streak count is only 2. So if we think back, the pointer was at 1, 0 and then 2, 0, but then the 0, 0 piece was never actually counted in streak count. So as a result, streak count never goes to anything higher. So if I keep going through, pointer 2 actually tries to start looking in the opposite direction. So instead of going to 1, 0, it'll go to -1, 0, which isn't on the board. So this skips over completely. So once I reach this if statement, the streak count is actually only 2 and not 3, but that's because I skipped counting the current piece that I'm on, right, which is 0, 0, and that piece should always be counted. So a quick fix is just setting streak count to 1, and basically that 1 is counting the current piece I'm already on. Different solutions are, you can, instead of setting pointer 1 to current position plus dir, you can just set it to current position, or you can do the same to pointer 2. Both of these all three of those solutions will fix the bug. And then same thing. Alright, cool. So now I am on the second bug. Let's run the same thing. So run tic-tac-toe board test. Okay, so now we have actually a new function, which is make move. And if we look through the make move function, so it looks like this. Alright. There's a lot of stuff below it, but that doesn't really matter because basically all this stuff above it is causing an issue. So if I actually click back to my run, what's happening is we can actually kind of follow it all from the print statements. It goes through like pretty much a regular game of tic-tac-toe, and what happened is this very last move basically puts an X in 0, 2. So 0, 2 should be up here. So that's an X. So there should be an X here, which should result in a win. But what happens is the make move function always returns whether or not it causes a win. But it's returning false, which means it's saying that, oh, this move does not cause a win when it should. So what you want to do is set a breakpoint and then debug. So now we stopped at this line, and this line basically make move should return true, but it's not. So if first things first, step in, let's go into make move. And then this is just like a fancy way of just like reformatting a function. I just thought it was annoying to have to type new position XY, so I made this like, I don't even know what to call it, like a wrapper function. But it basically calls a different function. So let's step in again to make move. And then make move is a pretty short function. And then the main points of interest is this return win and this check win. Because if you look at other places in the code, the only place that changes the win variable is actually going to be check win. I know this because I wrote the program, but if you don't know this, a good way to check it is just control click win and then control click win again. So then inside of control click win, you can look for all of the places that win is accessed. And one thing to note is if you see all these green icons, what that means is that's when win is being accessed, right? So it's these are just not modifying the values of win. These are read only. But if you see this orange one, it actually means you're changing or setting the variable. And there's only one place in the code that sets that variable to true. And that's actually this check win function, right? So if I go back to where my current line of execution is, so show current line of execution, if you lose this blue pointer, you can always click this show execution point, right? So inside of this make move function, all that's left is this check win function, right? That's the only thing that can set win to true, and that's what we want to do. So we know it's going to be inside of here. So let me just move down to here, and then let's step into. So now we're inside the check win, right? Our favorite function. So this function should be telling us that there is a win, but there isn't a win, right? So okay, let's go through the structure again. Here's some like regular, just like some variable setting up here. This is just like a sanity check, and then up here we have a for loop that iterates over all directions that we can win in. There's like different directions to look in. So we want to figure out, okay, what direction do I want to look in order to cause my win? Then I'll move to that direction and then inspect all of the streak counts and the pointers, right? Just make sure everything's correct. So a good way to figure out that is to look at the console, and then you don't have to go to the console. You can also inspect the last time that you ran the code. If you down here you have all the tabs that you're looking at. We're currently in debug because we're debugging the code, but run basically saves all of your outputs from the last time you ran the code. So you click run and you see your board again, and then remember that we placed a piece in 0, 2. So the direction we should be looking in is from the top left to the bottom right, right? So let's calculate which direction that should be in, right? So so we're moving positive on the x and then negative on the y. So that should look like 1, negative 1, right? Positive on the x, negative on the y. So now let's go to our current line of execution. So we're in debug. Let's click show line of execution. Okay, so this is the for loop. We want to go into basically the iteration of the for loop that has the correct direction. If we go to DIRS, we should look for like 1, negative 1, or the inverse of that, which is negative 1, 1. Both are valid directions. But we actually see we're missing that direction, right? We only have 1, 0, not 1, 1, 0, 1. Yeah, so this 1, 1 satisfies the diagonal, but it's actually the wrong diagonal that we're looking for. It's actually the other way. So the solution to this one is actually a little bit more straightforward. You just have to add a new position, 1, negative 1. And this new position allows us to calculate the win in that other diagonal that we missed before. So now if we close it and then run it again, everything should pass. Okay. Hopefully that made sense. Just to like overview that process again, we looked at make move. We found basically what the program was doing. It was like placing pieces on a regular game, and then on the last piece it was supposed to win, but it didn't win. So we ran into make move. Make move goes to this make move, and then this make move returns the win status. But then we're like, oh, okay, how does this function supposed to change the win status? If we go to the variable and then you click it again, you see that it's only modified inside of check win. It's only set to true in check win. So it has to be check win, right? Check win has to be the way that we set it. So then we went to check win, we clicked it again, and then inside of here, we were like, okay, I want to debug this for loop, but there's 4 different directions and only one of them will be relevant. So I want to basically set a breakpoint, waiting. I can set a conditional breakpoint waiting for me to hit the correct direction. That way I don't have to wait for it. So then I went to direction to figure out, okay, which one of these is going to be the correct direction. But then I realized there's only 3 of them. So we're actually missing a direction. And that's kind of how you hopefully get to this thought process.